So, hey everyone, welcome to our third lecture as part of our national research webinar series with BOTA and ORUK and BOMSA. Today is going to be about critical appraisal and literature review, and we're honored to have Professor Ben Ollivere, who is the Associate Pro-Vice Chancellor, Faculty of Medicine and Health Sciences, and Chair of Orthopaedic Trauma, and the School of Medical Theme Lead from Nottingham, and he's also part of the Biomedical Research Centre at the University of Nottingham. We also have Mr. Tamer Kamal, who is a post-CCT fellow at the Nepean Hospital in Australia. He has an interest in foot and ankle reconstruction surgery and neuroplastic foot and ankle deformity. He completed his training in and around London, in the Kent, Surrey, Sussex region, and he has a PhD completed in cartilage regeneration of stem cells. He is also lucky to have worked with the late Professor James Richardson, who made Tam have great decision-making as a surgeon. So to kick things off, we will have Mr. Tamer Kamal start us off. Thank you.
Good evening, everyone. Thank you for joining this, and thank you, ORUK, for inviting me. So we're just going to share my screens there. Is everyone logged in? Everyone can hear me?
Yeah, we can hear and see you fine.
Good. So first, I'd like to thank ORUK and BOTA and BOMSA for inviting me. So if we want to talk about critical appraisal literature review and how we make it simple, you can spend hours and hours talking if you want, but as a start, I thought that would be the easy approach to go through. So what I expect to learn from this meeting, I always put in some highlights that I try to fulfill. We need to learn how to recognize key concepts of critical appraisal, the need to apply critical appraisal in our daily practice, and be confident choosing and applying literature in your daily practice too. So anything requires a definition. Okay, and if you think about it, why are these important? They are very important in our research methodology and what we're doing. So in simple words and simple terms, critical appraisal is you are trying to find the loopholes, or in the study, you're trying to find what's good, what's bad. Okay, and then try to see if you can implement it in your daily practice or make good use of it. Is it good for your practice, bad for your practice? While literature review is just looking for the information. So you need to identify questions and search for it effectively. So looking for the information on that topic. So we apply this in our daily living. So as I said, this is a car savings approach. So if you think about it, now you're a doctor or still medical students, and you decide, oh my God, I need a car. So what do? You start thinking and thinking, which car? Okay, and that's the problem. So now you got questions, you got an object, and you got a question, which car I'm going to get? So you need to get information. So you ask your friends, family, Google, look for reviews online. Then you sit down, have a cup of coffee like I'm doing, and try to evaluate all the information, and based on this, decide. And it's a very important decision. A car is a very expensive investment. And in the end, you see the light, you buy yourself a bike. And that's for a couple of reasons. One, you can't afford to buy a car because your pay is crap. Two, it's the economic formulate a proper question. So you need to know what to ask and what you're looking for. I'm looking for a car, small car, economic car within my budget. So every time you make this question more specific, you'll be able to find a decent amount of data and search the literature more effectively. And then you'll be able to appraise that amount of data and evaluate the outcome and apply it by the car or by the bike. So when you're critical appraising, as we said before, we are actually just assessing the quality of the study. Okay, so we're looking how it's made, the design of the study. Okay, what type of study it is. Is this just someone saying, well, I compared apples and bananas, and apples are better for me? That's a simple opinion. Or this guy is saying, well, I compared this medication on this amount of patients and give this amount of patient placebo, and we've seen the effect, and this is the outcome. So there's different levels of evidence. We look at the methodology he did, implemented, how the data was collected, and how he analyzed the data. And all in all, there's a variety of ways to interpret the paper. You can interpret the information you've got. So you need to think, is this all done all methodically in a way that is standard for the practice? So like every recipe, okay, if you think on like cooking, I like eating personally. So I found that my wife has this recipe book that she inherited from her great-great-grandmother. And it's full of like old papers that have been slots in. So you look at the sample size. The sample, if you got 10 patients in a study, do you think this is a good study? Is it efficient for this study to make you change your practice? Or if you've got a study with a decent amount of patients, so before you have a study, you have to assume how much patients will be involved to get an efficient outcome. The selection criteria, who was selected for the study and how did you select them? Okay, so what was the inclusion and what the exclusion criteria? So if you made a study to say, I'm looking, this paper is showing that the effect of cervical spinal fusion in Middle Eastern population, that means, well, this is limited mainly to Middle Eastern population because you looked at certain factors from that group. Okay, you look at the measurement tools. So when you're making a study, you say, well, I'm going to assess the outcome of the study based on this. How long people survive, for instance, how long the implants survive, or what I'm looking at is this. I'm looking at, I ran out of money, for instance. How did you test this? And the most important thing you look for is any conflict of interest, also known as bias. Okay, there's various forms of bias, and I think Prof will explain that a bit more. But if you look at this great paper in here, this is a great orthopedic paper. From my point of view, it's mentioned in the BMJ, published 2011, still implemented now, and every orthopedic surgeon is following it. From my point of view, as an orthopedic surgeon, it's a very essential, important paper. So one of the common pitfalls of critical appraisal is you can't, there's various sources of bias. One, for instance, I'm citing my own practice, or it's one person practice. The way I selected the patients, I'd like this study to succeed. So I selected all the age group, for instance, in the fertility studies, they're all between 25 and 30. Okay, and permitted everyone in the risky age, for instance. Okay. Another common pitfall is how do you use the statistics? You can use statistics in any way to get a different outcome. So the use of statistics is very important, and this is why having someone who understands statistics. A proper statistician is very important when you're doing a study. Also, you need to be able to understand what's bad literature and the outcome. How can this affect long-term effect? So studying like the Wakefield study, and that made huge contribution and effect on the Western population. They said the MMR vaccine is directly related to autism. That caused lots of people to become an anti-vaxxer. Having vaccinated the kids, that second and third generation had lots of complications. And it took a long time. We started still struggling with the outcome of the study till now. Okay, and it's a good example to say and show how a small mistake and problem with appraising literature could lead to a worldwide problem. So, like every process in life, there's always a system, okay? And people will sit down together, start thinking how we can properly appraise a paper, for instance, what we need to do. And they create checklists, tools. Google have everything now. You can find lots of appraisal tools. I'll leave the link for some of them that you can find. And not all papers are equal. So I can't appraise a simple study or an observational study like appraising observational or multi-center control study. So there'll be different tools that check to every paper, and this is very important to look into. So this is a list of some critical appraisal program or tools that you can use. Okay, so as we mentioned, the importance of appraisal, why we need to do that. Think about it like the car approach. You have a limited budget. Okay, how are you going to implement all of this, that limited budget, to get the safety of your patients? So we cannot try everything. We need to look at the pyramid of and choose the ways we're going to implement this science and into our research, into our medical practice. So is this efficient? Yes or no? Can I apply it? Yes or no? Okay. Now, if you go to a literature review, so as you mentioned, literature reviews just come before critical appraisal. You need to identify the questions that you want and research a topic. And by researching the topic or doing literature review effectively and efficiently, you minimize the way you're going to do it, or the amount of time you're going to spend, and you get better quality of papers. So these are the steps that I think are very essential in any literature review. One, like any research project, you need to define the research question. What I'm looking for. Okay, I'm looking for, let's say, Easter Bunny. Okay, so I need to do a comprehensive search for this information about the Easter Bunny. And what I'm looking about that in here, am I looking in relation to Easter Bunny to chocolate, the historical event? I need to identify a very important question. So I need to put the question in a certain way to minimize all the unwanted outcomes and be more specific. And the more specific I'm going to be when asking about the Easter Bunny, for instance, and eating chocolate, you will find that you minimize the amount of information. Okay, you need to look how this abstract for every paper is written. Look, okay, inclusion, exclusion criteria, okay, how the study is limited by itself. And then you need to be able to extract and analyze this data effectively and get an answer to your question. So everyone is familiar with Making America Great. And if you are doing a literature of Fox News, okay, you'd be bombarded by lots of misleading claims or lots of literature. Okay, and that's what some people did. They used one word from here, one word from there, made a statement, and you looked for it. Some people believed it and made it science. So this is a very small example. You've got a huge amount of information out there, and the literature just narrow it. You need to know where to look and how to look. So I just went easily and put in Google Scholar, Easter Bunny, and you can see easily in here, you had 21,000 results just came out in 0.02 seconds. There's no way you're going to read 21,000 papers effectively. But if you look at, could just use the word and, so I'm looking for Easter Bunny and chocolate, like we mentioned, we decrease this amount to 5,000. You're more controllable and more specific. So you need to use your search tools more effectively and efficiently to answer your question and have a precise question when you do the literature search. So the common pitfall in literature review would be, and the most common is a publication bias. What's a publication bias? So we have this tendency in reporting good news. We want to show that we did something good. It's a human tendency. Okay, so there's more people who are reporting good outcome than bad outcome. Okay, lots of journals would like to get the attracting good outcome, new medicine, okay, new technique. But no one goes in and publish, I tried this and I failed. And if you think about it, you have more of the good than the bad, and that can influence your decision making. Majority of stuff is related to the researcher itself. What you put in the search engine will get you that outcome. So you want to add, if I say Easter Bunny and chocolate, you get a better outcome. Easter Bunny and chocolate eggs, smaller outcome. Okay, Easter Bunny, chocolate eggs in relation to diabetes, you're more focused, you're looking for something more specific. Okay, the way you deal with the data, extract the data and analyze it also can affect all of this. I think Prof will explain this a bit better. So common things that sites that people use, you can use PubMed, Trip Database, Google Scholar. There's a variety of search engines that you can use. And if you go to your local library, it will give you access to lots of websites in which you can download the papers you want, and they will help you finding these papers. They can do the literature search for you if you give them that specific questions and what you're looking for. The more specific your question is, the more detailed your answer will be and closer to what you want. So in simple and in conclusion, we're looking at critical pages of literature review. They are vital component of research. Okay. There is limitation, challenges. Most of your time will be spent in that preparation phase. You need to know what other people have done. You don't want to start creating the wheel. You want to make sure that you know what's there and you highlight what you can achieve and where you're going to end. Thank you. And I hope this was a very short introduction. Thank you.
Thank you for the lecture. Could we now move on to Prof. Ollivere's lecture? Could you please share screen?
I'll do my best. Can you see me?
Yeah,
Cool.
we can see it fine.
Excellent. Thank you very much for that, Tam. I'm taking a slightly different approach. So I'm going to talk to you about two things, really. One is how to find the paper that you want to read, because that's actually often the most difficult thing. And then to talk through really how to get the sense out of that paper. So why am I bothering to talk to you about searching? Well, this is the reason. If you do a fairly inclusive PubMed search, which is not the most inclusive of the indices, but is pretty good, you'll find that there are 2,308,000 musculoskeletal injury or trauma papers out there. So that's just in orthopedics. And if you look at the numbers published each year down here, you can see it's exponential. So it's becoming much, much more difficult to find the high quality literature out there that you need. So where would you go? Well, you can go to Google, you can go to PubMed. Embase is a good place to go. The difference in Google, which is a general search engine I'll talk about, and Google Scholar is also a general search engine, and the specific indices is the way that they search, and it's really important to understand that. You can look for review articles in trusted journals, or look at standard texts and look for their references, which are very carefully curated. Or you can go to research indices such as ResearchGate and places like that, or look at the digest journals, or go directly to your special journal website. The thing I want to introduce that people may not have used is the specialist search tools that exist, and there's some good ones. There's a good one in orthopedics, and they're mostly free, and it helps you identify the literature that you want. So how do we search? Well, the way that you search normally on the internet is you type something in and some results come up, and between you typing something in and the results come up, something called natural language processing happens. So the text that you take is taken, it's passed by an AI, it's converted into syntax, and the meaning is taken out of it, and then those search terms themselves are put through the search engine. So it is interpreting what you put in, and it accounts for spelling mistakes, similes, and all that kind of stuff. So what you write when you use Google or Bing or Google Scholar or what have you is interpreted. So it's not a direct search. If you go to one of the medical indices, you get keyword searching, which is totally different. And you can also get topic-based searching if you know how to do it. And then some of the specialist search engines use taxonomy-based searching, where each paper is categorized either automatically or by the library group that curates it. And so you end up with a sort of card index type system where the search engine understands what the papers are about and then turns those up for you. Normally a narrower range of papers, but a better, higher quality result. So what does that kind of look like? Well, if you think about a kind of typical problem, this is a patient of mine had open talus fracture. It's quite rare. I happen to treat quite a lot of open talus fractures, but a lot of people don't. So you might want to go and look up on a Friday night how to look after that patient. So you go to Google and you type in open talus fracture treatment. What you get is a curated range of things that the AI algorithm has passed from what you've written. So it's trying to take the sense out of what you're writing. So you can see it gives you some information about open talus fractures. That might be what you're looking for. It'll throw up a couple of bits and pieces for GPs, but it's unlikely you'll get much in the way of high quality academic output. So then you go to Google Scholar, which searches in the same way. It parses what you do, or parses what you've written, and tries to return articles that make sense to you. And you can see it's done a reasonable job. The problem with Google Scholar is the way that it collates its output. So Google Scholar uses the Google data set, which means that it's overly inclusive and includes a lot of information that isn't published in peer-reviewed journals. So if you go to PubMed or Embase, any of those places, there's a certain standard that all of those papers have undergone. They've all been peer-reviewed. They've all been entered into the National Library of Congress or a similar medical indices, and that's not true for Google Scholar. So that's worth bearing in mind. You get rapid, reasonable quality results, but the reasonable quality search result, but what goes into it isn't necessarily the highest quality papers. So just to explain NLP a little bit. So first of all, it takes your text, it works out what language you're in. Then there's a whole lot of pre-processing. So it tries to take out the syntax and produce the meaning. It then models the meaning of the sentence moving forwards and then produces your results from that. So what you're doing is you're not getting a direct search. Sometimes very helpful if you don't know what to ask for. If you go to a journal website, you get something of a difference. The same search term, and this is overly inclusive, right? So I've written open talus fracture treatment. You can see most of the things that it's pulled up on the first couple of pages are not to do with open talus fracture treatment. They're articles that have the word treatment in them, have the word fracture or open in them. And so you end up with a very non-narrow search. You've got to search a journal website or an academic website in a different way to Google. It's not producing the things that you would expect. So how do you do that? Well, you need to start using the filters on the left-hand side, or you need to narrow down what you're searching for. So if you simply write talus fracture, because this is an index from Bone and Joint, just of the public articles they've published, just put talus fracture and they're all orthopedic. You don't need to narrow it down any more than that. You suddenly find you've got a whole load of relevant articles, and then you can narrow it down a little bit more if you wish to in terms of the types of journals, the types of articles. So that's how to do that kind of search. I tend to use PubMed or OrthoSearch for my searching. PubMed was touched on a little bit earlier. So PubMed is an American thing. It's from the NIH. And there's a couple of things to know about PubMed. One of them is that there's a quality standard. So to get into the National Library of Congress index, you have to, 1, pay, you have to, 2, be a journal of a certain quality, and you have to, 3, provide a certain amount of data to upload. So consequently, what you've got here is a much higher quality set of articles. The problem is you're now searching a library, not searching a journal, you're not searching a search engine, you're searching a library. So you need to do that in a way that you would normally do for a library. And if you look here, I've got Taylor's open fracture treatment, same text, and I've got totally different series of results. These are all to do with treatment of the talus, but it's not been passed at all. It's not all orthopedic, and it's not actually mostly relevant. You know, you've got subtalar arthrodesis and so on, which is not really relevant here. If you then move onwards and apply a filter, so look, we've got the same search term, but I've clicked on the bottom here and I've put meta-analysis, you'll end up with simply those articles that draw together all of the papers. You see there's very few of them, but that's again much more relevant. We can now look at how we might want to treat. So if you're using a library-based system, at the very least, you need to be thinking about filters. You need to be thinking about saying, okay, I want this type of article, I want clinical trials, I want meta-analysis, I want case reports, I want whatever, and you'll find that your search results are much better. You can also change the sort at the top here. So the sort best match uses again an AI algorithm, machine learning algorithm, to try and provide you with the most relevant results. They're often not the newest results. So you can find often that you end up looking at an article written in 1973 as your first result, which isn't that relevant often to treatment today. But I commend you all to learn about the advanced search option, which is really very easy to do. And that's how, if you had an information specialist, and I've worked with information specialists in the past quite extensively, they would say at the very least you need to be doing this. So when you put your search in, you can see the ones that I typed in previously. It's just building a very simple search term. But using the pull downs, you can get something a lot better. So I've added that I want talus to be in the title and fracture. But I don't want osteochondral, because osteochondral defects of the talus not relevant. And I don't want OCD, which is the same as osteochondral defect, but can be used as an alternative in titles particularly. And suddenly I've only got 258 results. So I've gone down from thousands and thousands to 258 results. And if you look, this is page 1. By the time I get to page 12, these are still pretty relevant articles. So simply by producing an advanced search term in a library piece of software, you can get much more relevant results out. The other thing, final thing, I guess, on library-based software is that when you find an article that you want, because it's a curated collection, don't just read the abstract, don't just read the full paper, also look at what's on the right-hand side here. So you can find the similar articles button, for example. You click on similar articles, it shows you articles that it thinks are based around the same types of authors, the same topics, and the same study design, which again is often a good way of finding things that otherwise would be difficult to find amongst those millions of potentially relevant musculoskeletal papers. The other thing that you can do if you're feeling really geeky is look at the mesh term. So mesh is one of the ways that libraries identify and catalog articles. And so this particular paper, you can see how it's been cataloged. It's been cataloged into adolescent, adult, bone screws, fracture fixation, so on and so forth. So you can then search based around those mesh terms, which again is a very quick and simple way of using indices that are under the bonnet in something like PubMed to allow you to identify the articles that you want quickly and early on. If that all sounds too complex, there's a couple of other options for you. Plug for my own personal journal, which is Bone Joint 360. That has summaries in it. Summarizes most of the useful articles. If you can find something in 360, you'll find that it's got a plain English language summary that you can read, which will help significantly understanding. The other quick and simple thing to use that's starting to pick up a bit is OrthoSearch, which is also from Bone and Joint. It works in a very different way to other search engines in orthopedics. So this has a taxonomy built underneath the underneath the mechanics of it. So the way that taxonomy works is that each article has keywords that are produced by an AI algorithm. So I've just gone out and tailor fracture treatment. You can see it's got, you can see the keywords that it's then picking up, you know, tailor neck fractures, open reduction, internal fixation, measure scales, indices, orthopedics, and so on. So this is a very carefully curated series of articles. It tells you about the impact factor of the journal. It tells you how much it's been cited and so on. It's a very, very helpful way of searching. And you can see just with that same straightforward search term, you get 85 results, and they're all pretty much relevant. If you then narrow it down, author searches using two boxes on the left-hand side, you can get to the 23 clinical trials that exist in this area very, very quickly. And those are the papers you actually want out of the 30,000 or so that PubMed threw up on the first search. If you end up doing this properly, rather than doing all those things I've just described, you'll end up with some very complex search terms. So this is from one of our systematic reviews published a little while ago. And you can see there's 31 parts to this search. So searching really is a science. It's not a straightforward thing to do. And if you build the searches properly, you end up pulling out. So this is a systematic review meta-analysis we did for rib fractures. See, we pulled up 874 articles to start with, then 599 by the time you got the duplicates. You then screen them all, and you end up actually writing your article based around the potential for 10 papers, of which only 5 were relevant for evidence synthesis. And when you come to review those in a meta-analysis, you look at where they are, you talk about risk of bias and what have you, and eventually you'll produce some forest plots which tell you the outcome of interest aggregated from the high quality papers. For those who don't know how to read a forest plot, it's pretty straightforward. You've got the papers on the left-hand side of the studies. You've got the event rates of whatever it is of interest. So at the top, we've got mortality. The one below, we've got duration of mechanical ventilation, and so on. And you can see each individual paper and what it estimates the risk is, whether you're favoring operative or non-operative, because this is operative versus non-operative for rib fractures. Same here for mechanical ventilation, and so on. And then the diamond that you've got at the bottom is the outcome of all of those papers taken together and where the estimate of the effect is. So you can see in the world literature today, because this is a relatively recent systematic review meta-analysis, there is some significant, doesn't cross the one line, evidence to suggest that fixing rib fractures reduces your chances of getting pneumonia, and that it doesn't reduce your chances of death, although it might with some more evidence. You can see all those papers on the left-hand side. So that's all I wanted to say about searching. I'm just going to use the last 15 minutes I've got just to talk about, once you've got your paper and you've sifted through all the nonsense, how you get that the best you can out of that little golden nugget you found that potentially contains the information that you want. So I've done quite a lot of editorial work, both editing and reviewing and writing my own articles and so on. And a lot of people in that side of things will say, you know, the 3 things that are important in terms of getting published are, is it new, is it true, and is it interesting? You know, it can be new and true, but not interesting, and it won't get published. The thing we're interested in when we read articles is this: is it true? You know, is what's said in the title, the abstract, and the conclusion correct? And a surprising amount of the time, it's not. I'm just going to go through a few things that are of interest in terms of working that out. Most, if not all, people on the line will recognize this. It's one of the few sculptures from the last century that people recognize. This is the Thinker, yeah, and it's one of Rodin's sculptures. And the interesting thing is about context, because most people think of the Thinker as being this large, nearly 2 meter tall man who's contemplating philosophy. And there's Rodin himself. And what they're not aware of is that these are upscale replicas of this original small sculpture on his Gates of Hell sculpture, which sits in the Musée de Rodin in Paris. It's worth going to have a look at if you're into that sort of thing. That's only 70 centimeters tall. So it's all about context. And if you take things out of context, it's very easy to come to the wrong conclusions. So what do we mean by context in terms of academic work? Well, the first thing is, where's it from? You know, is it from a large institution that sees certain types of things? Is it from a number of large institutions? Is it from a small institution, specialist hospital? Is it one of those things that's been done over many years and just two patients have been put in each year? You know, is it a selected population? What is the population that's been studied? And that'll tell us, is it generalizable? And what I mean by that is the data that's presented in that paper relevant to practice elsewhere? So I work in a major trauma centre, and what we do in the major trauma centres in the UK is relevant to other major trauma centres in the UK, but probably not to any other trauma system, because it's an unusual system in the way that it works, and probably also not to non-MTCs in the UK either, if we're talking about multiply injured patients, because it's not deliverable unless you're working in that system. Next question you should ask yourself is, who wrote it? Did they get paid to write it? Was there a grant involved? Were they somebody who that's their pet thing and they've been doing it for a long time? Then you should be thinking about what's missing. Is this the whole population that it should be? Are these the right centers? What's the time period? Is this 30 years of one surgeon doing 2 operations a year and then presenting a good 600 patients at the end, but it's a whole lifetime's work? And what else might have changed? Because in general, when we do studies, unless they're randomized controlled trials or fully funded studies, they take a long time. And during that period of time, things can change. And what's been done then might not be relevant. And indeed, if there's a change in practice, it might not be that change in practice that makes a difference. Good example would be in hip fracture. The things that we've done in hip fracture over the years have improved mortality, but also older patients are better treated now. They live longer. So it might not be just what we do that affects their outcomes. It can also be what everybody else is doing, what GPs are doing, what the geriatricians are doing, what the new drugs are doing. So the first thing that you should do when you look at a paper, and give an example, it's going to be one of my papers, so I'm not digging at anybody else, is read the last page. This is a bit nobody ever reads. After all the references, at the bottom, there's the author information. It tells you who the authors are and where they are. It tells you what their jobs are. So there's me, look. And it tells you what they've each done in the paper. So it tells you what essentially the input of each person has been, okay? So you'll see that mostly, because this is a paper that we all did together, we've mostly done the same stuff, okay? Then you need to look at the funding statement. And this is really important. We didn't get paid to write this paper. There was no drug company that was providing us with money. And there was also no conflict of interest. So Ben Marston's one of my PhD students, had an active grant at the time, but it wasn't relevant. And I've got active grants, but they're not relevant to this particular paper. And also we had got institutional review, which is important. And if you've got audit permission, then that'll be in there as well. So please do read that conflict of information statement at the back end, because that'll tell you something about the context and why the person's written the paper that they've written. Next thing to think about is, where is this paper on the evidence pyramid? Is this just an expert opinion? I did a case, and this is what I thought. Is it an editorial? Is it, I know about this? And sometimes that's relevant, but it needs to be taken into context. It is somebody and just their opinion. Or is it a case report or some case control studies where there's just a series of small numbers of patients treated in the same way? Is it an unselected cohort where you've taken all the patients presenting with a particular diagnosis and you've looked at those individual patients and you've come to the conclusions based on that whole population? Or is the study randomized in some way so that you've taken the whole population, treated them differently, but you've done so arbitrarily so that any differences are to do with the treatment, not to do with differences in the population? Or is it a systematic review and meta-analysis where lots of these high quality studies have gone in? And that's the next thing to think about when you're reading the paper. Where is it? And this is level 1, level 2, level 3, level 4, level 5 evidence. Okay. So if we look again at this paper of mine, what most people will do is they'll just read this bit. Okay. And this bit here, the abstract, is something that I've written, or somebody else has written and I've edited, or somebody else has edited, and it's there. It's designed partly by the journals, partly by the authors, to present the best parts of that paper. So you'll read that there's 1,255 patients, and in the subtitle, which makes it seem quite important. And you'll read that we assess the value of the clinical frailty scale, and I'd hope that we've done this in a reasonably objective way, such that reading that abstract doesn't mislead you, but it might do. So how should you read the paper? Well, instead of looking at the abstract, the first thing to do is look at the methods to find out what was done. You need to read a paper out of order. You need to make some notes as you go along. You need to then look at the figures and tables, which will tell you what the patients actually were and what the key outcomes were. Then you need to make your conclusion as to what you think those figures and tables show, and check that against what they've written in the results. are they actually giving you the correct results? Then you need to look at the statistics. And if we've got time, we'll talk a little bit about some statistics and some of the newer statistical techniques that people might not understand. And then I'd go and look at the background, because people tend to write the background information to their results. So the background information often is not objective like you think it might be. It's written to the results of the study, because very few people write the background to their paper before they've got the results, right? They do the study, then they write the paper. So they already know what the paper shows when they write the read the discussion, and then read the conclusions and see whether you agree. And it's an interesting thing to do because often people don't. So if we were to look at the methods for this paper, it's a shortish methods section, but there's a few things that we can take out of it. It's prospective observational cohort study, so it's unselected, yeah, and it's prospective. And what we did was we recorded the clinical frailty scale, and we've reported the patients that went in and the patients that didn't go in. So they were all presenting with a hip fracture, and if they didn't have complete data and they were under the age of 65, they were excluded. And we've reported how we've done it, and it's to a standardized methodology, which is the standardized audit hip fractures of Europe, which is the best way pretty much of including everything you need to. And our index test is a clinical frailty scale, and our reference standard is Nottingham hip fracture scale. So we've reported what our standards are, and we've reported what kind of care the patients had, and we've talked about how we collected our data and what data we collected. So if I were to summarize that in my notes as I was going through reviewing a paper, as I might do, I would write, this is a prospective cohort with all with the clinical frailty scale. Under the age of 65 were excluded, standardized data collection, and the CFS was compared to the NHFS reference, standard care and outcome data collection. So that seems on the surface of it to be a reasonable way of trying to work out if the clinical frailty scale tells you much about hip fractures. That's what I do to start with. That doesn't take you very long. Next thing I do is I go to the patient's demographics table, because that tells me a bit about the patients that have gone in. It tells me about the distributions, whether or not there's a large number in any particular group, and if there's not. And the thing that sticks out for me when I look at our own paper, because this is unselected, is you can see there really aren't very many patients who have severe frailty, despite the fact it's a hip fracture study. You know, there's only 2 male patients with a CFS of 9. There's only 3 male patients with a CFS of 8. And so actually anything over 8 or 9, probably we can't draw many conclusions from. And you get that straight away by looking at the data. And you can also say something about face validity in terms of the data itself. You know, you can see that as the patients go up in frailty, they also reduce proportionately in the numbers that are in their own homes. When you get to about 6, the numbers the numbers of patients that are in their own home go down, the numbers that are in residential care and nursing home go up. So that kind of tells me that the data set looks reasonable for what I would expect. And then I start looking at the figures that have been put in, and this is just about the frailty scale and mortality, risk of complications, institutionalization, and so on. And you can draw a couple of conclusions from this without any statistics at all. You can say, okay, as you get more frail, in general, you're more likely to die after a hip fracture. So that's a useful conclusion to make. Wasn't really known before we did this paper. And you can say that actually those patients who are not terribly frail stay a little less in hospital than the others. We've already said 8 and 9, we can't really draw many conclusions from because there's very few patients. And then there's no real difference between those that are frail and not. And the same with our complication rates. If you're not frail at all, low complication rates, otherwise you have a complication rate that's about standard across the whole cohort. And the same for institutionalization. The more frail you get, the more likely you are to be institutionalized after your hip fracture. So I've now got essentially all the results that I need from my paper by looking at that, and I can also look at my Kaplan-Meier and my ROC curve if I choose to. And what I'll then do is I'll go back to the statistics and see what they've done. And just in 5 minutes, I'm going to go through a couple of stats things, because these are really important. People get stats totally wrong, and most of it is very simple. So first thing is to understand what data we've got. With continuous data like height, we do t-tests and u-tests, and we can do an ANOVA. With categorical data like apples and oranges, smokers, non-smokers, and what have you, need to do contingency tables. And we can test for significance by using a chi-squared test for large numbers of patients, or Fisher's exact for low numbers of patients. If people aren't using those simple statistical tests, which are the ones you should use for simple analyses, you have to ask the question, why have they used something complex when something simple would be better? And then you've got this sort of grey area, which I'm not going to go into, which is what to do with ordered data, with ordinal data. And the answer is you can either treat it as continuous data, or you can put a threshold. So this is open fractures, obviously. And, you know, they are types, but the grade 1, 2, and 3, they do increase in severity. So you can make a decision about that. The other thing to look at is whether or not the study has been designed as paired or unpaired and have to use the correct test. So if you're doing a before and after, like a hip replacement, you should always use paired tests because it's the same patients pre and post. And if people haven't used paired t-tests, you need to ask yourself why. And probably the reason is that they've been trying to sort of slightly make the stats look better, make the outcomes look better. As an aside, this is from in fact the similar paper that Tam mentioned, which was a Christmas BMJ paper. It's a kind of tongue-in-cheek thing about IQ of surgeons and anaesthetists. So here we have our IQ of our anaesthetists from that paper and our trauma surgeons from that paper. You see the trauma surgeons have a much higher IQ than anaesthetists. Now, if you just do that study again and you make the sample size bigger, you get a lower p-value, because the p-value is the confidence of the difference in the means. It's nothing more. So there's the size of the p-value, the smaller it is, doesn't tell you anything about the size of the difference at all. And that's a really important thing to understand, is that it's the precision of the estimate, nothing more. What we do need to know is about the minimally clinically important change. And if that's not reported in the paper and it's a clinical paper, you need to be really suspicious, because minimally clinically important change is how much variation in outcome is important to a patient. You know, being able to walk 8 foot further with one type of hip replacement versus another in 10 minutes makes no difference to a patient. Being able to walk half a mile further in an hour makes a big difference. So that's about what's relevant to the patient. That's minimally clinically important difference or change, and then statistically significant differences. And both of them are needed for clinical relevance. So p-value is the observed difference from chance alone. The minimally clinically important difference is, does the observed difference matter? And if those things aren't reported in the paper, you've got to ask questions about whether or not that paper itself gives you clinically relevant results. I'm going to talk very, very briefly about a couple of things, because I've got 3 minutes left that I think might be of interest to some of the more senior people on the line, or may not be. If you are trying to look at outcomes for implant surgery, what have you, then for most of the papers that we have and most of the ways that we study things, we have an issue with the way that the studies are set up, because they're natural experiments. We don't do all the operations at the same time. So we've got different lengths of follow-up. So, you know, if you were looking at hip replacements done by a particular surgeon over a period of time, you've got them all being done at a different point in time, and the length of the follow-up for each patient is different, because the date that they were done on, the date they were seen, is different. So you've got these kind of random exposures, and that's very difficult to handle statistically. So one way of doing it is simply to line them all up and say, okay, what's the survival at a particular point? The difficulty with that is it doesn't allow for incomplete data. So if you were to estimate the survival of the plant here, then you'd say maybe it's only 20% survival at 5 years, but it's actually just that these patients haven't lasted long enough to see whether or not they would survive or not. So the way that we deal with that, and we deal with death and missing data, is that we do something called Kaplan-Meier analysis. And Kaplan-Meier analysis allows for different sizes and different follow-up lengths and loss to follow-up. And when you're interpreting the Kaplan-Meier graph in a paper, what you're looking at is you're looking at the 2 lines, and you need to make sure that the authors have reported the confidence limits as you go along. So although these lines are quite different, you can see the confidence limits essentially overlap up until here, okay? And so up until 10 days, although there is a big difference, there's no statistically significant difference. So you're going to start from the position these confidence limits overlap. So is there a difference or not? Probably not. The way that you're going to find out is if they've got the know-how to do it, they will have done a curve difference. And this is again from one of my papers, because it's bad to slate other people's papers when you're talking about it. And then there is a curve difference here, and you do the log rank test to look at that. So this is survival again for fixed versus non-fixed rib fracture patients in a match series, and it's one of the reasons that we now fix ribs is a few of us reported results like this. So the other couple of techniques I want to very briefly introduce to you are the difference between linear regression and logistic regression, because people get upset and don't quite understand it. So for linear regression, what you're trying to do is you're trying to relate 2 variables. So you've got on your x-axis, normally you've got your independent variable, on the y-axis you've got the dependent variable. And what we're trying to work out is as these 2 vary, does one affect the other? So independent variable, we think influences are dependent variables. So this might be, for example, height and weight. Okay, so we might think as people get taller, they get heavier. And so we'll have a series of observations where we look at their height and weight, and then the analysis technique will plot a line of best fit. It will calculate some confidence limits for you based around that. And it will produce a number, which is the R² value. And that tells you what proportion of the variance in Y is explainable by variable X. So what proportion of the change in weight in your group, if we're looking at height and weight, is explainable by what portion of the variation in weight, is explainable by height or the other way around. And it also allows you, sometimes you're looking at data sets to look at out. So that's linear regression. It's a form of supervised computer learning. So what's logistic regression then? Again, it's a term that people use without really understanding the difference, I think, sometimes. So if we're looking at our weight and height graph, as I suggested there, this would be our linear regression analysis. We plot a best fit curve where we'd have an idea of where we are. But if we wanted to use that to distinguish between obese patients, that would be difficult to do, wouldn't it? Because people who are 6'4" are likely to be heavier than people who are 5'2", but the obesity is related in some way to that. And so what logistic regression does is it looks at known outcomes and then tries to work out how you divide that cohort in either 2D space if it's just two-factor, or multi-dimensional space if it's a multiple factor regression analysis you're doing. So if you think about linear regression and you've got some patients, you've got your weight and the height, and some of them are obese and some of them are not, it's very difficult to plot a distinguishing curve here. And what logistic regression does is that it allows the algorithm to produce sigmoidal type curves, and that will allow you to distinguish reliably between those that are not obese and those that are obese, independent of their height and weight. So that's the difference between those two often confused terms. The other thing I want to touch on very briefly, just because it's used a lot at the moment, is propensity score matching. Propensity score matching is a way of accounting for differences in groups. So if you've got two populations as shown here, so we've got a control group and my treated group, but they're different. They're a different age, different gender, different whatever. Making a comparison between those could be to do with the treatment, or it could be to do with the fact the groups are different. So what you do with propensity score matching is you use an algorithm that takes selected individuals between the control group and the treated group and matches them according to their propensity score. What you end up with then is you end up with hopefully a perfect overlap between the two, a much smaller group size. And it's a way of doing an experiment based on observational data that accounts for some of the biases that you would see if you don't randomize the patients. Not as good as randomizing patients, but better than simply just doing cohorts. So what you're doing is you're accounting for the differences that you know are likely to be there for things like smoking, obesity, steroid use, and so on, say if you're looking at fracture healing. So you look at those confounders that you know exist and you match based around those. So that's how I would read a paper. That is some of the statistical things you need to understand. It's pretty simple. You need to find the right papers. You need to go through it, not in the order that the author wrote them. You need to come to your own conclusions about what the results are, who they're relevant to, and have some idea about whether, you don't have to be able to do the statistics, but you have to have some idea about whether or not the statistical tests that have been used are appropriate, because if they're not, then probably that whole paper needs to go in the bin, because the person that wrote it didn't understand the analysis they should use, and you can't really trust anything that's written there. Thank you very much.
Thank you so much for the lecture. We don't have any questions at present. So I'm just going to give everyone a minute just in case anyone wants to write a question, and I'll relay it to you.
Obviously, extremely thorough set of talks. No questions asked. So people fall asleep at their keyboards.
No, it's very thorough. Okay, we don't seem to have any questions for both of you. So I'd like to take this opportunity. Thank you very much for giving up your time to lecture today. I'd like to draw this meeting to a close, and please join us for our next lecture on the 26th of April at 7 p.m, where they'll be talking about study design. Thank you very much.